viewers, welcome to my channel. We are still continuing the tutorial on linear equations and linear inequality. In this episode, we want to take solving questions of absolute value inequality. Linear equations can also be combined with an absolute value. So if you are new, consider subscribing to the channel. So we are saying that if u, which is standing in for any algebraic expression, as in this case 5 minus 2x, x minus 4, any algebraic expression, and c is also a positive number or a positive constant, as we can see 3 and 7 are the constant we have in this, then the solution to any of these questions is going to be, if we have absolute value of u, that is the algebraic expression, is less than c, let's take note, less than c, it could also be less than or equals to. The rule here will apply to either it is less than or equals to. The solutions are the numbers that can satisfy the negative of the constant less than the algebraic expression. Just the algebraic expression less than the positive value of the constant. Then 2, if the algebraic expression is u, the solution of absolute value of u greater than c, which could also be greater or equals to c, the solutions are the numbers that can satisfy the algebraic expression being less than negative of the constant or the algebraic expression being greater than the constant. So this your solution will be fine. You find the union of this solution to mean the final answer. So taking the first one, we have to solve the absolute value of x minus 4 less than 3, which we can see is in the first position. So this is going to be, right away, what do we say? The negative of the constant. Okay, let me write the question first. So the negative of the constant will be negative 3 is going to be less than the algebraic expression x minus 4 less than what? The positive of the constant. So this is the solution. But it can be solved further because this is a compound inequality. We need to have only x in the middle. So we can add 4 to the 3 side. 1, 2, 3. So here is going to be minus 3 plus 4 less than x minus 4 plus 4 will be 0. So I have this to be 3 plus what? 4. And I believe minus 3 plus 4 is just like 4 minus 3. So you have 1 less than x less than what? 7. So the values of x that satisfy this solution. So the solution set is going to be a set of x such that 1 is less than x is less than what? 7. So this will be the solution set of the first one. If you have an absolute value and a constant that is less than, it will also be less than or equals to. Then for the second aspect, we know if I have x less than 1, it also means what? 1 is more than what? X. These two expressions are true. If x is less than 1, it also means that what? 1 is more than the x. So you can see that this expression is not in this form nor in this form. We need to have our absolute value before the inequality sign and the constant. Absolute value, inequality sign, and the constant. But I am seeing the constant, the sign, and the absolute. So I can change that using the definition from here. So per this, if x, as we are seeing, is less than 1, it also means that the 5 minus 2x is also more than what? 7. And I believe we can place this now under the second method. which says that absolute value more than constant. Absolute value more than what? Constant. What does it mean? It means that the u is going to be less than the negative of this, or the u will be what? More than the positive of this. So this means 5 minus 2x will be less than negative 7, or here 5 minus 2x more than what? 7. So the solution is either this or this. Now we can solve each of them separately and find the union of our final answer. Taking this one first is going to be, I need the x to be on the left, the constant to go. So minus 2x, I'm going to subtract 5 from both sides. Will be less than minus 7 minus what? 5. Subtracting 5 from both sides. That will give you minus 2x less than minus what? 12. But I believe we are looking for the value of x. And bear in mind, in our introductory lesson, we mentioned that if you are dividing an inequality equation, if you divide them through with a negative sign, the sense of the inequality changes. So this is going to be over minus 2x over minus 2, this change to greater than minus 12 over what? Minus 2. And if you cancel this, you have x to be more than what? Positive 6. So for the first one, we have x to be more than what? Positive 6. Then let's take the second one. 5 minus 2x should be more than what? 7. In this way also, we keep our negative 2x greater than what? 7. Then we subtract 5 from both sides. So this will give you negative 2x greater than 2 per the subtraction. We still need to divide through by negative sign. So negative 2x over negative 2, the signs will change from greater to less than 2 over minus 2. So what happened here? You get your x less than what? Negative 1. So in the first case, x is more than 6. In the second case, x is less than what? 6. In combining the or find the union of this, we can see that we cannot solve this. We can't combine these two to be in one symbol combined inequality, as in negative 1 less than x less than what? 6. It won't make sense, because negative 1 is not less than what? X. Because it is the x that is less than the negative 1. So it means negative 1 is more than x. Good. Then here also, x being less than what? 6. X is not less than 6. X is rather what? More than 6. So the solution set is going to be a set of x such that x is what? Less than negative 1, or x is more than what? 6. The 2 will be the solution, because we can't have a continuous range between these two. So this is what the solution will be if we are having in this case greater than for absolute value. All right, I believe the two examples explain the concept that we explained in the beginning. Any questions that is on this nature, I believe these two examples can serve as a guide for you to be able to solve questions of that nature. Thank you so much for watching. Like and share, subscribe to the channel. Bye bye.